Today's talk is on thinking in components, building powerful UIs in React.js. My name is Kevin O'Hara. I'm the CTO of Level 11. I've been a Force.com MVP now for 2 years. I've been doing Salesforce development for about 7. And I actually calculated last night, I've been writing code for 20 years, which makes me feel ultra old. So we're going to be talking about React today, but the first thing we're going to do is kind of take a look at like the current state of the market in terms of client-side MVC frameworks. So who here does client-side development, JavaScript, MVC frameworks? Okay. How about like Backbone people? They're Backbone people? Yes, I know you guys are Backbone people. Angular? Woo! Ember? And who's doing React yet? All right. So fairly new concept to most people. Okay, that's good. But we're going to talk first about what are the challenges with some of the current MVC frameworks, and then we're going to take a look at React and how that kind of solves some of those problems. And then we'll talk about React. We'll talk about JSX, which is a complementary technology to React. And then we'll take a look at using React in Visualforce pages, because I'm assuming a lot of you are Salesforce developers as well. And then we'll actually do a demo real quick, and we'll show you kind of how this works. So the challenges of MVC. So one of the biggest issues in most MVC frameworks is managing the views. So everybody knows like the view component of the MVC framework is really the DOM representation. It's really like the rendered UI. And so this is a really important thing to get right, but it's a really difficult thing to manage with typical frameworks. So this example here, I just kind of whipped up this little, like it's like a music player, Spotify type demo here. But what traditional MVC frameworks do is they leverage heavy, aggressive re-rendering of views. So as data is changing in your application, the frameworks are typically re-rendering a lot of UI. And so when you look at an example like this, if I'm going to add a new song to my playlist, I'm going to click a button, click Add New Song. And a traditional MVC framework might re-render everything that you see in green, because on the left-hand side, we've got the playlist, which has a counter of the tracks, which needs to be updated. We've got the actual playlist in the center, which is going to have a new track now, which that needs to be updated. And then you have a track counter in the upper right, which also needs to be updated. But when you really think about it, all we did was add a track. So what should we be re-rendering? We should be re-rendering just the individual smaller components in the page that actually changed. So, just the counters for the track listings and just adding a track to the list. But typical MVC frameworks don't really handle this very well. Another big challenge of MVC is a lot of them implement what's called two-way data binding. Who's familiar with that concept? Okay, so for those who aren't, so two-way data binding is essentially in JavaScript in memory, you have a data representation, usually a model or a collection or something like that, and it's bound to a view in the user interface, so that when data changes inside of JavaScript in memory, the view is automatically updated. And then inside of the view, which is the DOM, if somebody clicks a button or interacts with that and changes data, it's also updated in memory. So it keeps those two things in sync. So in theory, this actually works really well until your application starts to get more complex. So you'll eventually find, like with larger applications, and we'll talk a little bit about Facebook's challenge and how they solved it. But one of the biggest challenges is when you start to have multiple views that are representing data in one of your models and trying to keep all of that bound. And then your application starts to get more complex when you add more models and more views. And eventually, this two-way data binding becomes this spaghetti relationship of events happening and data changing and things trying to stay in sync. And it's really easy to get stuck with really terrible problems, like even an infinite event loop where some view is updating a model, which is updating another view, which is updating a model, and it's really hard to debug. And so especially for like new developers, maybe you hired somebody new to your team, they come into a large application that's really complex like this, it's very hard for them to understand what's going on in the application. So I have a little code snippet up here. Does anybody know what we're looking at up here? Okay, so this is on the left-hand side, this is actually a Backbone view. And on the right-hand side is its associated template. So in Backbone, you have this concept of a view and a template, and that's what's used to actually generate your user interface. So the view is really the logic on how you want to render the interface, and the template's actually like HTML markup using some sort of templating language like handlebars, or maybe you're using underscore templates or something like that. So who's here familiar with the concept of separation of concerns? Okay. So separation of concerns basically says that your code base should be very modular, and modules should be responsible for one thing and one thing only. And if so, you find something that you're building is actually responsible for managing two different parts of your application, you should split those out so that they're each responsible for one thing. So at first glance, you might look at the view and the template and say, okay, that's just a common, separation concerns there. But it's really not. It's actually sort of the anti-separation concerns. They're actually sort of the same thing. So when you think about it, your view is user interface, the template's responsible for rendering the user interface, and you have to intermingle these two technologies to actually build your user interface. And they're in separate files, and they're separate technologies. So this actually becomes a big challenge to manage, especially as your application gets larger. And these things are really, it should just be one thing. It's just the representation of your user interface. So what is React? So we just talked about a bunch of the challenges with MVC frameworks. And now we're going to take a look at React and kind of how it solves some of those issues. So React was it's basically a development framework developed by Facebook in 2013, and it was designed to solve a bunch of very specific challenges around complexity of MVC applications. Facebook essentially got to the point where they said, our application, our user interface, the ones that you guys use on the public internet to go interact with Facebook, they're getting so complex, MVC just wasn't scaling. And they were finding that their application was actually getting really unpredictable. They would have bugs that would mysteriously go away and then show up later. They had trouble keeping views up to date. And then they had a lot of troubles getting new developers involved because there was such a steep learning curve to just understand what was even going on that it was causing them a lot of problems. So they wanted something that was a lot more expressive, a lot more modular, and really what they found was the main issue was just the view component was the main issue in scaling their applications. So React is really just the V in MVC. It's just responsible for managing your view layer. React also has some really good practices sort of built into it where it encourages you to break up your user interface into very, very small components. And when you do that and you build a library of these components, it's really easy to start to assemble new user interfaces and kind of reuse some of these things so that you're not always like rebuilding the same views and templates over and over again and copying and pasting. You can start with just building a component library and then start to structure your application however you see fit. Components they can be stateful, so they can actually have some sort of like data state associated with them. And they also have this ownership pattern, which is really nice. So basically, if you look at a React application, you usually have like a top-level component, and then it renders components inside of it. And the top-level component, or whatever higher in the hierarchy, is sort of responsible for telling its children components on how they should be rendered. And it does that through passing properties down through them, and other callback functions and things like that. The other thing that React, this isn't necessarily a React thing, but React sort of really likes this one-way data flow concept. So we talked a little bit about the two-way data binding challenges, and really the best use of React is to not try to do two-way data binding, but actually try to create a one-way data flow. And I'll show you a little diagram in a minute that will help make that more, make that a little bit easier to understand. And then in React, there's some magic there. And I didn't totally understand this in the beginning, but when I watched a couple talks on it, and it made a lot of sense. So in the first part of the talk, we talked about like that aggressive re-rendering that most MVC frameworks do. React is completely different. And in fact, what React does is it actually calculates two versions of the DOM that you're working with. So you have the actual DOM that's rendered in your browser, which is your current user interface. But anytime data changes and React detects data changes, either through like setting new properties on components or like state getting updated, it calculates what's called a shadow DOM. So it actually rebuilds the DOM in memory. And then what it does is through a really interesting diffing algorithm, it goes and detects the individual changes between the shadow DOM and then the actual DOM in the UI. And so then it can do intelligent things. Rather than like re-rendering my whole interface for the music player app, it can say, okay, I see that there's only a couple diffs here. This number has changed, so I just will do an individual DOM manipulation to change that number. this track counter has changed. I'm just going to update that. Maybe I need to add a CSS class to one element. But this is really, really cost effective because you're not re-rendering the whole user interface. You're just making individual DOM manipulations. And so every time your data is changing in React, it's constantly recalculating the shadow DOM and figuring out exactly what it needs to do to get the current DOM up to date. So that's a really important component. I think one of the really magical things that React does. So JSX is a complementary technology to React, and what it does is it allows you to have an XML-like syntax for expressing UI. At first glance, it looks like you're writing raw HTML, and you can write it right in your JavaScript files. So we talked also about the separation concerns, where you're separating the view logic from the template logic. You don't do that in React. It's all one thing. So you're actually constructing a React class, which is essentially a view, and then you can write JSX right inside its render method to actually build the component for your user interface. It's just part of your view, and that I think that makes a lot of sense. It also makes the scalability of your application a lot better because now you don't have things distributed in so many different files, and you're not dealing with multiple technologies. You're just using the power of JavaScript, and that's what really JSX and React is all about, is allowing you to build a very expressive user interface just with JavaScript. You have the full power of JavaScript at your disposal. And there's actually two ways of doing basically writing your render method in React. You can write it in JSX, which, if anybody's looking at this example here on the left, this is a really simple hello world example, but you'll notice that this is a JavaScript file, but is this going to run in the browser? No. It's not going to run in the browser because you can't just return a div with hello world inside of it. So this actually requires a precompile step. So React has some tools to actually generate valid JavaScript to generate the UI. And that's what you're actually seeing on the right. So when you actually compile from pure JSX into your actual view, it rewrites it into React's JS library for constructing the DOM. Some people actually prefer. There's nothing that says you can't just write your React views like you see on the right. I find it a lot more appealing to be able to write sort of HTML-like markup right inside of my view, and then it just requires a precompile step. So React inside of Visualforce, it behaves how you would expect it to behave. There's no real gotchas here. And just like any other MVC framework, if you're building sort of this single-page app, you don't really have a lot of markup that goes into your Visualforce page. You're essentially rendering an HTML page. You're dropping in your JavaScript files, and then all you need to do, and this is true for most MVC frameworks, is just provide some sort of target where you want to render your app. So in this example here, we just have a div ID of main, and that's where everything's really going to be rendered. Okay, so let's just talk a little bit about the demo app first, and then I'll kind of get into it, and we'll go through some code, and then I'm going to leave plenty of time at the end for question and answer. So one of the things that, again, is really important, I think, if you want to get away from the typical MVC paradigm and get into something that's a little bit more expressive like React, is really start to understand this concept of the one-way data flow. And it's really changed my view on how we build applications, and it's something that at level 11, we're using heavily, and we've got some new products out now that are actually leveraging React, and we were actually able to build our app in sort of record time as compared to other backbone projects. And a lot of it is because just the simplicity of the one-way data flow. So if you look at the application up on the screen, I wanted this to be a really simple demonstration, so I created a single app file, which is just the application state. So this app is going to manage tasks. It's just going to be a quick task adder on the account page, and the application just manages what tasks it currently has, allows you to add new tasks, and actually used. Who here is familiar with remote objects? New technology from Salesforce. Yeah. So with remote objects, I was actually able to do this app completely client-side in just a single JavaScript file. So it does all the server communication through remote objects, which is kind of cool. So if you look at the application, you'll see that the blue line represents the data flow through the application, and the purple lines represent events coming from the DOM back up to the application. So you'll see it creates this circular pattern. So there's no two-way data binding back and forth. You don't see the application bound to each of these individual components. It's just one big circular flow. And so what happens is the application goes and requests the current task for the account, and sends that data down through the main component. And then again, React has this hierarchical component model where the main component will then render the task table. So it's going to start to generate a table of the tasks. And then that table is responsible for rendering each of the rows inside of it. And all that data is just kind of passed down through that whole funnel of components. And then inside of the DOM, we have a couple events to respond to. So one is the new task event, and then that's just sent to the application and says, hey, application, create a new task. When the new task is created, same thing happens. That data, all those tasks are funneled back down to React. And so again, I'm sending basically all the data down through the view layer, and I'm letting React sort of figure out what it needs to do with the user interface. Does it need to re-render things? Does it need to change things in the DOM? A couple other notes. I won't get into it too much, but this is built with Browserify, so it's a module system for JavaScript, and it actually leverages like sort of the power of Node's module system in CommonJS to build modular JavaScript. So everything is modular. All right, so we're going to do a little demo. Okay, so this is going to be a pretty simple demo. I just want to spend a lot of time actually looking at the code because I think that's probably going to be the biggest mystery of everything. So, so we have a typical account page here. Is that viewable by everybody? Okay. So typical account page here, and then I have this quick task section here. And so the goal of this was I just wanted a way to do data entry on this account, adding tasks, and do it lightning fast. So I can click New Task, Follow Up, click OK. Did I lose my network connection? I might have lost my network. Let's see. There we go. Okay. Follow up. And then I'll add a couple more. Click OK on those. Okay. So just to prove that there's no smoke and mirrors here, it actually is creating the tasks. And I can go in and I can click Edit, go complete some of these. Click OK to kind of commit those, and then double check. All right, yeah. So now I've got my completed tasks. I've got new tasks here. So you know, nothing crazy here, but I think you'll find once we dig into the code that it's actually really pretty simple. Okay, so let's take a look at the code. Okay, so we already saw a screenshot of this. I'm not going to spend a lot of time on this, but this is like a really simple Visualforce page here. All I needed to do to get going was just define that you know, that div where I want to render the rest of the application, and then import my JavaScript files, and then we're good to go. And then I mentioned I have one single file for my task app, and it's essentially just a big JavaScript object with some methods on it for, you know, getting tasks, which is fetching them from the server using remote objects, adding a new task, which is like creating one, deleting, changing statuses or whatever. So I have a bunch of like methods on here that I can call to you know, set new properties on individual tasks, create tasks. It's very, very, very simple. One thing I did add here was I made this an event emitter, which that means that I can actually emit events from this and then respond to those in other areas of the application. But pretty self-explanatory, very simple app. But let's get into my main file here. So so this is like the main.js file. This is like what you import into the page and like get your React app going. And all I need to do to start a React app is render a single component. And if you remember, the key here is that it's a hierarchy, right? So you're rendering a main component, and then you're letting it, you know, the rest of the components kind of render underneath it in the hierarchy. So all I'm going to do is I'm going to pull in this main.jsx. Again, this is JSX and not JavaScript. I'm going to pull in that main file, and I'm going to render an instance of that. And then on my application, I'm going to call start. So this is the top level component. This is the main.jsx. And this one's actually pretty simple. I mentioned before that components can be stateful. The state that I'm concerned about in this component is whether I'm in the loading state or I'm in the ready state. And so what I can do in my render method is I created a little helper function to check that. So this is going to return me my content. I can call get content here, and I can check the current state, either return like a paragraph tag with like a loading text in it, or actually return the next component, which is a task table that I created. And in that task table, I'm passing in the array of tasks that I currently have. So now we go to the next level in the hierarchy. So now we're generating the table. It's pretty standard markup here. It's just a table definition. And then inside of the body, I'm going to generate a bunch of rows. And again, this is like where the power of React comes in. I'm able to use JavaScript to generate that content. I don't have to worry about another library like handlebars or underscore templates or something to actually generate the UI and do an iterator to go build all the rows. I can actually just write it in JavaScript and just inject it right in there. So I like writing these little helper functions. So I have a get rows function here that just reads the properties that I passed in from the top level component, which is the task, and I generate now another component that I've created for each task called the TaskTableRow. And so you'll start to see this pattern of one component rendering another component, but passing the data down to it that it actually needs for itself to render. And so now we're at the bottom level component where we have the TaskTableRow. And actually, last night I was looking at this, and I could have actually broke this up into even smaller components. I think that's the big win with React, is when you start to get down to very, very small reusable components. But I'll show you what I'm doing here. So I'm generating a table row here. So it's a table row with a bunch of TDs in it with the values. So we had the name of the task, the status, and then an action section where you can click edit or delete. So in my render function, again, this is just a single task table row. So I'm just going to generate a TR here, and then I have helper methods to generate each individual data element in the table. And this is where I could have broke this up into two separate components, but I sort of did this all in one file. But I just created helper functions here. The state that we're worried about here is whether the current task is in editing. So if you remember from the demo, when I click edit on one of these, you'll notice like the UI changes, right? So it opens everything up for editing, and then at that point I can change values and click OK. So I basically just do a conditional here. I check and see if it's editing. If it is, then I'm going to render it different. I'm going to create inputs and allow you to actually add, change the data. Otherwise, like I'm just going to return like the raw text. So hopefully that gives you kind of an example of why this is so powerful, because if you're already writing JavaScript, you're already building applications in JavaScript, why not use JavaScript to sort of express your UI rather than have to intermingle multiple technologies? So, but the one thing I would have done is, I think the next step here would be, I could actually take each of these individual TDs here and actually make them their own components. Or maybe one component where I pass in different properties or different state. The one other thing I want to talk about too is the last piece of it, which is now responding to events from the view. So we just talked about the edit button. So how does that work? So here's the action TD. So this is the TD that contains like the buttons to actually go in and edit or delete. What you do here is you can set on-click properties, and these on-click properties you can just point to other methods in your application. So again, we're not doing data binding here. So we're not this click action is not bound to a specific model or a specific task. It's just a click action, and I'm just going to handle that. And I'm going to let the application figure out how to handle that. So here's one. So the save task. So you're going to find that. So I'm going to update the state of the current component to so now it's not editing. So like if you've saved it, then it goes back to the just the default view state, and then it's going to call a function on the app. It's going to say save this task, and all I'm doing is I'm just keeping an index of the task. It's really, really simple. So I'm just saying update that that particular task, and then if I had edited any other fields, those those properties would already be updated on the task, because there's other functions in here that kind of handle that. They tell the app to update, the status or whatever on the task. So now if I go back to the app, we have the save task method. And so what happens here, the task is saved. It lets, the top level component know, hey, everything's saved. And it sends the whole data back down through React. And React sort of figures out at that point, do I need to re-render anything? The whole time I'm not really thinking about the DOM and what it's doing. I'm really just thinking about the application logic and what I'm doing in my application. So, so that's I think this is really a very intelligent way to build an application, especially if you're going to build something that's, that you want to scale, that's going to get larger over time, that's going to get more complex. I mean, every app starts small. I'm sure we've all dealt with projects where it started small, and by the end, it was just such a nightmare to maintain. We found that with Backbone, sort of the hard way. So I feel like this is something that's going to help us to make more scalable applications. So we have like 5 minutes left, and I thought I'd open up for questions. And then we have there's a microphone on the front too. So if you could yell really loud, you can yell, or you can walk up and ask a question at the mic. Not long. So probably a couple months. I'm looking at my guys down here. Yeah, probably a couple months. So there's a little bit, if you're coming from traditional MVC too, allow yourself a little bit of time to really start to grasp the concepts, because it's a lot different. It's a different way of building applications, and you have to fight the urge to fall back to your old habits of like, where's my two-way data binding? Like, I want to go touch the DOM. Yeah, you got to let React sort of do its thing. So we struggle with that a little bit, and then you will have this like eventual like nirvana moment where it's like, okay, I get it now. Like, this makes sense. This is how I want to build my applications. Any other questions?
Do you have any designers? Because I would think they'd not be wild about going into JavaScript to edit how things work.
Yeah, no, that's a good point. But you have to remember what the alternative is, right? So the alternative is going to something like handlebars or underscore templates or like some other templating language, and they all kind of suck. So I mean, it's kind of a hard thing. Like if you're working with a designer who's also like really a front end developer, to me it seems like this would make a little bit more sense because at least what it does is it doesn't intermingle a bunch of additional syntax, additional semantics that you get from like another templating language. I mean, to me, I think most people, I mean, it looks like just raw HTML. And there's a couple nuances there, and obviously, like when you define a component, it sort of has some more of like an XML-like syntax to it. But I feel like I don't know, like it's for somebody like that who's non-technical but is digging into the code, their life's going to be tough either way. Any other questions? What's that? Minification? Yeah, so it's fine. So the only thing that you have to do is in your build process, the first step has to be the JSX compilation, which I could pull up the keynote. Oops, this one, which turns what's on the left into what's on the right. So it basically just takes your JSX syntax and it parses your JavaScript file, and then it spits out a valid JavaScript file. So that has to happen first, but then if you run it through Uglify, which we do, then it's fine. Yeah. Any other questions? Going once, twice?
Are there any big companies backing React?
Facebook. Yeah, it's in terms of, so he asked if there was any big companies backing React. So this is widely used through Instagram and Facebook, which obviously is the same company, but yes, it's picking up a lot of traction. It is relatively new. Things are changing, so proceed with caution. But I think it's going to kind of hit its momentum here pretty soon. It seems like a lot of companies are interested in it, and it's sort of bringing a new concept to how people actually build single-page applications, client-side applications, and breaks away from traditional MVC, which is, problematic. There are some cases where React is really not a good fit, at least not now. From our experience, if you're doing anything with like heavy animations and chained animations, it's not great. Because one of the things that React is they don't really want you reaching down and touching the DOM, and a lot of the animation libraries want you going down and touching the DOM and moving things around and sort of having like a like a jQuery API to it and just kind of doing that. I mean, you're not really supposed to do that React. Those things are supposed to be expressed through state. They have a couple things to help with animations, but if your animations are very complex, one of our applications is very complex, then it's just not a good fit. at least not now. Question? Anybody? I hear you.
Too far. Is this? Oh, so are you using? You may have already said this, but are you using Flux with your React applications? And can you talk a little bit about how you think about it? And it's kind of a strange thing, so I'm trying to get my head around it.
So Flux is really like it's an application architecture. It's not really like a like an open source project or like a tool chain or anything like that. It's really just an architecture that Facebook designed, which makes the one-way data flow easier. I sort of did some of that, but not in the way that that Facebook does it in their demos. It's interesting. I think for if you look at the way that they implement Flux for their application being as large as it is, it makes a lot of sense. It separates things out really nicely into to action handlers, to your application layer, to stores, which is where all your data is held. For like an example like this, it was completely overkill because it was like there wasn't enough there to justify like making it that complex. So he wrote everything in one file. But it is kind of interesting, and it's a good design if you do want the one-way data flow.
Thanks.
Any other questions? I'm sorry? Yeah, there are some frameworks. Full disclosure, we're not testing it yet. No, yeah, there is. There's a couple frameworks right now. Do you remember what they're called? Jest. Yes, we played with it a little bit. We just never got to the point where we were ready to go full bore on it. But anybody else? Well, I think that's about it on time. Well, I appreciate the time. I know everybody's probably working off a hangover, but thanks for being here. Appreciate it.